Hello again, you sick, twisted weather freaks, and welcome to a special edition of This Week in Weather. I'm your host and meteorologist, DT, from weatherrisk.com here in Central Virginia. Your captain of chaos, your colonel of confusion, your commander of catastrophe. Let's talk about This Week in Weather. And again, like I mentioned, this is a special edition. We're going to look at the second half of the winter of 2024-25. And we've got several things to talk about here. Obviously, here comes La Nina. There's no doubt about La Nina strengthening. The first half of February, highly unfavorable for any kind of significant winter weather threats outside of New England or the Great Lakes. And even then, I'm not even certain. The warm cycle might last to February 20th, and then there is the potential for one late winter surge here, February 20th to, let's say, mid-March. So we'll get to that as we go into it. So let's take a look at where we have been and where we are. So we start out here by taking a look at the key premise for my winter forecast. The key aspect was that we're going to have a developing La Nina in the autumn of 2024. It would either be very weak or never fully materialize and be neutral. So in either case, either neutral ENSO conditions or a weak La Nina significantly increases the chances of seeing near normal temperatures with occasional outbreaks of severe cold and winter storminess. So this map here below will show you different areas in case you are not familiar with the ENSO regions. This is off the coast of Peru. Here's the date line. This is towards, the Solomon Islands, New Guinea. So you can see the region here we're looking at. There's several different regions, but the critical one here is 3.4 in the red and the blue. That's the one we look at to determine whether we are in El Nino, La Nina, or neutral conditions. Now the European model back in November showed this, and you can see here the red line. Very nice. And you can see that it briefly had weak La Nina conditions in January, and then it just rapidly, maybe February, very borderline, and then fell apart. Now the December one was a little stronger, but again, it was a weak La Nina. That also had it falling apart in January. And here's the CFS. Now the CFS was a little stronger, because the CFS here, this was as of November 4. You can see back again. This is back in November. It actually dropped it down from -1 in late December, and then you could see it was weakening as it went to January, and then up neutral by late January, February, and March. That's what the assumption was. Okay. Now the reason why this is important is because this is the typical moderate La Nina 500 millibar pattern, which is why it's so generally bad news for the East Coast, the southeast regions of the continental U.S., the CONAs. Now, there's a generally widely held belief that all La Nina events produce the same general 500 millibar pattern during the cold season, and this covers from November to March. That's bullshit. That's wrong. That's not correct. So this image shows how, forgot to put the S there, shows the typical moderate La Nina, 500 millibar pattern. It features a positive anomaly ridge, in the northeast Pacific. You can see that right here. A negative trough and anomaly in western Canada. There's your ridge, there's your trough anomaly. And that produces or favors another ridge, a flat ridge in the southeast United States. So you don't get a lot of blocking here. You don't get a lot of cold air. It's not very generally an unfavorable pattern. In fact, if you look at the historical record, I do not believe there have been any instances where New York, Philly, D.C., Baltimore, maybe even Pittsburgh, I'm not certain, certainly Richmond, where you've had an above normal winter with snowfall and a moderate La Nina. Weak La Ninas, yes, but not with moderate or strong ones. So I just want to point that out to you. Now, this is the weak La Nina pattern. This is very different. Obviously, you can see the strong ridge right here in Western Canada, and this implies cross-polar flow. This is a negative EPO. That's what that is, a negative EPO pattern. And your mean trough is around 80, 85 degrees west longitude, around the Ohio Valley, and you do have some ridging and a potential negative NAO, Greenland block, trying to develop in southern Greenland. So this is a very, very different pattern. Now, it's not common. Most, like I said, weak La Ninas are not common weather patterns at all. To show you what this looks like, again, this is from Golden Gate, so weather services on the West Coast. They have excellent La Nina and El Nino temperature and precipitation biases and profiles. And again, I showed this from back in my winter forecast in November. Of these 8 weak La Nina maps, 2 of the 8 showed temperatures that were either that were generally much above normal in the eastern CONUS. And you can see that being 2016-17 and then 2020-23. Okay, then you had 2 of the 8 other winters were near normal in the eastern CONUS. You can see that here and here. And then these other winters were all below normal. So again, the 4 of the 8. So you generally has a bias with weak La Ninas for at least either normal or somewhat below normal temperatures. At least you have a ball game. When you have a moderate or strong La Nina, your winter's toast for the most part on the East Coast. I mean, you might get a couple of minor events, but you're not looking at a great winter or even a normal winter. So weak La Nina gives you a ball game. That's the point here, okay? And in terms of precipitation, the same sort of thing. Again, you can see that of the 12 winter maps below with weak La Nina, okay, in the deep south, 6 winters had below normal precipitation, 3 were near normal, and 3 had above normal. On the East Coast, 5 of the 12 were below normal, 2 had above normal, and 5 had near normal. So you can see it's almost an even split, okay? And in the Midwest, only 1 La Nina winter featured below normal, 6 had near normal, and 5 saw above normal. So La Ninas generally favor the Midwest, okay. Now, why was December and January so cold? Well, there's a couple of reasons for that. The image here below shows you the 500 millibar from the past winters that have featured weak La Nina event or neutral conditions, generally weak. And the polar vortex, as you can see, is forced way south here. Oops, yeah, there you go, it's right there. There before it comes south. Now, it's still very, very strong, but it's forced to the south. Okay, so this can allow for significant Arctic air mass outbreaks, usually in the Rockies and the Upper Plains, Western Canada, the Pacific Northwest sometimes, not so much the East Coast. And you have your positive anomaly here in the Aleutian Islands, and you have a little bit of blocking here in Scandinavia and southern Greenland, but not much. Okay. Now, when you have a combination of a weak La Nina with a westerly phase QBO, all right, and that is, again, a reminder, high-level jet stream that runs along the equator at the very top of the atmosphere. It often produces a pattern known as a positive TNH. This is the positive TNH pattern. We had this in 2013-14. So here is your positive anomaly in the Eastern Pacific, not on the West Coast, in the Eastern Pacific. And you have the positive, and then you have the polar vortex is forced southward, but it still remains very strong. Normally, when the polar vortex is very strong, you have positive Arctic oscillation, and the Arctic air mass stays locked up in Canada with very few Arctic outbreaks. This is the one way with a strong polar vortex you can get winter in the eastern U.S. when you have a positive TNH pattern, and the vortex here is forced southward. Let me blow this up a little bit so you can see it. Okay, the vortex is forced southward here. Okay, and then your ridge is not on the southeast U.S. coast, but off the coast. All right, so that's what we saw in the winter 2013-14. And to show you what those temperatures look like, this was from December 1 to February 28. You can see how cold it was. And then for the second winter from January into 14-15, but especially January 1 to March of 2015, you can see how extremely cold it was in the Great Lakes, the Midwest, and the Northeast quadrant of the U.S. So that's what the positive TNH pattern does. That's exactly what we've been experiencing. Oops, another typo there, sorry about that. Okay, so you can see here, this is the upper air pattern on the left from January 9th, and here's the one from January 22nd. Classic TNH pattern. The polar vortex is very strong in both maps, but it is displaced to the south, as you can see. You have your ridge is not on the west coast, it's in the eastern Pacific, but you have a broad trough here across the Midwest, and you end up getting your winter storms and significant Arctic outbreak. You also have cross-polar flow, which happens often in the TNH pattern. Look at the lines from Siberia going straight down from Canada through the Arctic into northwest Canada down to the central U.S. So the positive TNH pattern almost always means cross-polar flow. That's the other important feature. Cross-polar flow, positive TNH pattern, okay? Good. That's what we've been seeing, and you can see that right here very obviously. There's the cross-polar flow here and here coming out of there. It's just very obvious. They should teach this in the weather books. Okay. Now, the other issue is the La Nina. Now, this is from December 17th. And I want to look at it as the area highlighted in C. All right? And notice that off the coast of Peru, it's warm. All the cold water is here in the Central Pacific. This is known as a Molokai La Nina, Central Pacific La Nina. All right? And if you look at the subsurface readings, you can see there's a pool of cold water around -4 degrees centigrade, which is pretty cold, at about 100 meters down, at around 140 to 160 degrees west longitude. That's where it's located. And that was driving the weak La Nina. All right. That's what was going on. Here are the changes. This is January 27th. Big change here. Huge. I cannot emphasize this enough. Not only has the water here intensified, the cold water, but is now spread back into ENSO 1.2 off the coast of Peru. This is unheard of. I have never seen this with La Nina. All right? Developing in late January, February, and expanding, pushing back to the east. I've never seen that with a Molokai. Now, I'm sure the other instances, I just haven't seen it. I can't recall it offhand. So this is really, really a significant development. Really quite significant. And if you look at the subsurface, here we go. We can see what's going on. So in the upper left, January 19th. Look at the pool here, January 19th. -4 to -6 degrees centigrade right here. Now, notice how it's beginning to push to the upper right towards this would be Peru right here, ENSO 1.2 in the upper right corner. See how it's pushing here, expanding? That wasn't the case here. See, it was flat. There was no bias to this. Okay, it blows up a little bit. You can see a little more. Okay, see how it was flat, running west to east. Okay, that's not what's happening here. And then here, the bottom right, this is January 28th. Now the cold water is definitely pushing up in the upper right corner. And that's what this expansion of the cold water driving towards the surface into ENSO 1.2 is why we are seeing this. Okay? And if we look at the charts, in terms of the actual, we can plot it here. Again, I presented the map so you can see the bottom. On the left-hand side, we have region 3.4. On the right-hand side, 1.2. So here, notice, okay, we were, December 1st, we were very weak, and then we dropped. Then we bounced back up again. Now we're dropping again, around -1.2. Okay? Consistently negative anomalies here. This is La Nina. Weak, but there. Now it's strengthening again. Now this is 1.2. Notice early in November, December, we were actually quite warm. Then stabilized. Now it's dropping rapidly. See the drop right here at the end. So again, this tells me we may be entering a moderate La Nina. And that's bad. As I mentioned earlier, this is moderate La Nina. This would be bad for the second half of winter if we end up in this pattern. Okay? That's what this would be bad. If you like cold and snow. Now, if you like it mild and snowless on the eastern United States, cursed be thy name, then you would want this to happen. But if you like winter weather, this is not what you want to see. But unfortunately, I think that's happening. Okay. Now, the other variable here, the second half of the winter, is the MJO. Now, we have two models here to look at. There's lots more of them. I'm just presenting two of them. I don't want to overwhelm you with too much information here. Okay, here's the European ensemble. I'm going to blow this up a little bit. Okay, and here's the GFS ensemble. Okay, so the European, we are here now going to phase 4 and 5. Then it curls into the neutral circle. See the circle there where that's saying the MJO is going to have no impact. When it's in the neutral circle, it's too weak, it has no impact. You see how it gets stuck down here in the neutral circle. Now, some of the members are going into phase 7 and 8 by late February. See that? Now, that would be significant if that happened. But the mean, the average, is going into neutral circle. Now, the GFS does the same thing, but notice here, when it gets to phase 5, it goes into 6 and 7. These are very mild phases in late February for the eastern U.S. It does not go into the neutral circle. So which solution is correct? I don't know. I'm not going to bullshit you. I don't know which one's correct yet. Okay? If the MGO turns into the neutral circle, it would set up the potential for return to a colder pattern in mid-late February. If it goes to the neutral circle, but it might not. I don't know yet. I'll show you the bias here. You can see, look at this. Look how warm phase 4, 5, and 6 are in January and February. Egads. So, that's why February 6th, that's why phase 6 is a big freaking deal. If it doesn't go into phase 6, okay, maybe we got some possibilities here. But you can see what that's like. Okay, let's look at the next 5 days. This is January 30 to February 3. There's the upper low. It's coming east out of California. It's going to generate low pressure. You got a ridge here in the eastern United States. All the cold air is all bottled way, way up north of the U.S.-Canada border. This is a rainstorm, pure and simple. All right, but also notice there's another big trough coming here in the Gulf of Alaska. Okay, so that's going to drop down in here and cause a new upper low to form. So the result is rain. Okay, this is Friday and Saturday, Ohio Valley, Mid-Atlantic, East Coast. It might be snow in upstate New York and northern New England. If it is, it's very minor. It's not a big deal. Now, all the other point here is a lot of places in the eastern U.S. are pretty dry in terms of moisture, so moisture they could use some. So that's not the worst thing in the world. Temperatures, okay, only place which is near over the next 5 days is upstate New York and New England. You see temperatures just a couple, slightly below normal. Everybody else is above normal. All right. Next, let's look at the 6 to 10 day. So, 6 to 10 day, a lot to talk about here. Let me go over it slowly. We're going to look at this. First, you see the block here in Alaska. That's the negative EPO trying to reform. All right? That causes an upper low and a trough here in the Pacific Northwest. That causes a ridge to form from the Rockies to the East Coast. But at the same time, this block here creates a new Arctic high. You can see that right here, February 4. Okay? 1044 millibars. Pretty strong. Not the strongest, but pretty strong. And the flow is coming out of Canada along the U.S.-Canada border. So the high is going to try and drive cold air back into the upper plains, the Great Lakes. Now, the question is, how far south is it going to get? Not that far south because of this ridge here. So the cold air doesn't make it, let's say, south of Interstate 80. Okay. Then the energy gets kicked eastward from this upper low, and you start getting a low pressure. This is February 6th. The low pressure comes out of the plains and tracks up into the Great Lakes, and everybody is quite mild on the East Coast from Pennsylvania, New York border, all the way down to Alabama, Georgia, Mississippi. And then you've got rain in the Ohio Valley. And even rain upstate New York and New England. I mean, this is a mild pattern. That gets February 5, 6. All right? So there's another event. That's rain. Okay. Now, and then we go beyond that. Now things get interesting. Here, the European map on the left, the GFS is on the right. Both of these models this afternoon, which was a surprise, have the negatively tilted trough in the Midwest going down to the southeast states. You see that? They both have it. See it? Right there. That would allow a cold front to arrive with low pressure on the front, and rain could change to snow. Now, both models also have another piece of energy, a shortwave, in the Pacific Northwest and Southwest Canada. So we're not going to have a big ridge on the West Coast here. Okay? Now, so I don't know if this is correct or not. This does not seem right to me. Maybe, but I don't think so. Especially if we're going into phase 6 MJO. Again, if we don't go into phase 6, like I said here, then maybe these solutions are correct. Okay, so this is February 8, 9, right? Right at the end of the 6 to 10 day. The other important feature is look at the EPO developing again in Alaska. Okay, trying to push back to the east, away from the Bering Sea into Alaska and northwest Canada. This, if correct, would begin to establish cross-polar flow and bring more Arctic air back into the central and southern portions of Canada, which would have implications in 11 to 15 day. So, what does that look like? Well, here comes the front. GFS, this is the European model. The front comes through. You get enough cold air, so you got moderate snow in the Ohio Valley, northern Pennsylvania, maybe New York and New Jersey, New England, and New York State, New England. South of that, it's mostly rain. In the southern half of the Mid-Atlantic, it might end as snow. I don't think so, but it might. Okay, and this is February, like I mentioned, this is February 8, 9. Okay, the problem is the ensembles don't show that. Okay, that's the operational, that's the ensemble. Operational, ensemble. These are not the same thing. The mean trough of the ensembles gets pulled far back to the west into by the Mississippi River, it looks like. And so, it's a very different looking map. So, now it does look like the ridge is getting pushed from the southeast U.S. into the central Atlantic. So the heights are lowering. So that's the good news. This would imply that the pattern might return to near normal temperatures after February 10th or 11th, if that is correct. Also, both models have the EPO here in Alaska, okay, pushing back, building the cold air in. Again, notice the line. See these lines coming in Canada? Let me blow this up a little bit. You can see what I'm talking about. Bring this front. Okay. You see the lines here? Oh, bring this front too. Okay. That's his cross-polar flow straight from Siberia into building up the Arctic air for another outbreak. And the temperatures, 6 to 10 day, looks pretty warm. Okay. Now, in the 11 to 15 day, February 9th to 13th, what happens? You can see the ridge is now being pushed to the east, and as a result, the southeast ridge gets suppressed a little bit. And now you're getting more cold air coming in, and you're getting a broader trough. Now, the mean trough is still centered in the western United States, but this is a little better. If you were to get low pressure forming on the front here, it would probably track more west to east, not southwest to northeast. So this might be a little better. So this kind of indicates the cold air getting into the eastern U.S. in some capacity, maybe not a full blast, but definitely getting a little colder February 11, 12, 13, something like that. Okay. Now, in the 11 to 15 day, beyond that, if you go to, let's say, February 12th and 13th, again, these models are from yesterday. The European and the GFS, they bring back the ridge. So, again, this is very much up in the air. So, I don't know. Okay. So, it's 50-50 on this. The key here is the phase 6 of the MJO, or does it go neutral cycle? Now, yesterday, these models were saying, oh, that's phase 6. Now they're going neutral. So, you want me to tell you what I know? I can't tell you. I don't know. I don't know yet. So, I'll know soon, but not yet. You just have to wait a couple of days. That's all. Okay? And this is the way it goes in the weather business. I'm not going to bullshit you if I don't know. Okay. Now, this is, you can see today, this is 0Z January 30. The models are showing the cold air getting in. Now, this is obviously only a degree or two below normal, but at least it's not a blowtorch. Okay. And then finally, the last week of February, the European Weekly is showing a very strong negative anomaly here, just north of the Great Lakes, like it did in December for January. Again, in December, the European Weekly, day after day, showed a Arctic outbreak, a negative anomaly getting pushed far to the south. That's what this is showing now here. This is February 23rd. Possible. We'll have to wait and see. This is just the first time I've seen this, so it's a little presumptuous, but let's follow it the next couple of days and see whether or not there's any consistency here. Okay. So the summary. The last, oops, that's not what I wanted to say. No, that's the wrong summary. Did I put it here? Yes. Okay, so the threat of significant snow or ice in the Ohio Valley, New York State, New England is low, but there is a scenario where you could see some winter precip in these areas. The pattern is going to turn cold. If it's going to turn cold, it won't be until February 15th, maybe February 20th. Now, there are reasons to believe the last week of February there will be return to a normal or even below normal readings. There is a chance we could see a late season Arctic outbreak last few days of February into the first few days of March. We don't know that yet. And again, what would help that a lot would be if the MJO would move into phase 8 and 1 in late February, March. That would increase the chances of a second surge to winter. Okay? And again, you can see that here. If we were to get into phase 8 and phase 1, like the European, you can clearly see the European is having a lot of these lines in phase 8 and phase 7 to phase 8 by the end of February. The GFS is not. The GFS has nothing in phase 8, mostly in phase 7. So big differences here. And again, I can post the Canadian, the Japanese, the Australian. Every one of them has a different solution, just no consistency yet. So when we get some consistency, I'll know more, then I'll let you know. But until then, we're just going to have to suffer through it because that's where we are. So that's where we stand right now. Anyway, that's a presentation. Go Eagles, you know that. I'm an Eagles fan. I've been a diehard one my entire life. That's it. So we'll see what happens next week, and maybe the data will have a bit more certainty with the middle end of February. This is meteorologist DT from Weather Risk. I will see you over on the Weather Risk Blue Sky page, over on the Facebook page, and over on the website.